Right, so for today, not really notes. Again, we're just going to look at the worksheet and do some of these together. You can look through number 1 already. Looking at number 2, again, the if is use the second column first. That's the main thing. And use that column to figure out which piece of the equation you want to use. So g of negative 5, well, negative 5 is less than 0. Therefore, we'll use square root of 9 plus negative 5. 9 minus 5 is 4. Square root of 4 is 2. G of 8. Well, 8 is bigger than 0. Maybe I should label those again. So I'll use branch B or part B or equation B. Again, use the x value to pick which branch to use. Do not plug it into both of them. So square root of 9 minus 8 is square root of 1, which is 1. And then lastly, 0 is sort of the switchover point from A to B. But for g of 0, am I going to use branch A or branch B? B, because it includes the equal sign there. So, evaluating piecewise, not really a big deal. Please use the if first, and then use the then.
When writing the answers, do we need to have like g of 0 equals 3?
So that's a good question. The best answer would be g of 0 equals 3. Since I split them up like that, I think it's clear who goes with who. But what you wouldn't want to do is to just out here to the side write 2, 1, 3, because then I'm like, well, what's 2 and 1 and 3? So make sure it's clear what's what. All right, 3, 4, and 5 is just more practice on the same thing. Let's jump to number 7, because now we're going to graph each piecewise function. Yes. Ominous music plays in the background. If I was really good, I could edit my video and put that in the background as I started talking about graphing piecewise.
No, we'll just have her as our professional like sound.
That's right, just sound machine, soundboard over there. So what's the key x value for number 7? Where does it change from one function to the other? 2. So what I'm going to do, there's a change at x equals 2. So this is not an asymptote, but it is a boundary. It's not part of the graph, but I'm going to put it on there because at x equals 2, that's where we're changing from graph A to graph B. So for graph A, when x is less than 2, so on the left-hand side of the graph, I'm going to graph y equals absolute value of x. For graph B, when x is greater than or equal to 2, on the right-hand side of the graph, I'll graph y equals 5. So y equals absolute value of x. What's that look like? Yeah, that's the v. There was one of those on the quiz. And that's the parent function. There was no shifting or anything for this one. So on the left side, that's pretty easy. On the right side, what happens when I get to the wall there? Do you remember? Yeah, I'll stop for sure, because if x is bigger than 2, I can't graph this graph. Like, these are neighborhoods, like you can't. So it's open circle, closed circle considerations. So for graph A at 2, are we going open circle or closed circle? Open, good, because we're not equal there. So I need an open circle there. Like, absolute value of x doesn't own the wall. He's got to stay off the wall. The other guy has the equal sign. He can get on the wall.
If the absolute value was, let's say, compressed, like 1 over 2, how would that look?
Say, like the quiz?
No, not like the quiz. Like just happened.
I mean,
Jason.
it's fine. Like the absolute, if it's compressed, the slope would be less if it was 1/2.
Okay.
And if it was flipped upside down,
Oh, yeah.
there'd be a negative out front,
Wow, that'd be amazing.
right? And that'd be, look familiar?
Yeah,
Amazing.
okay, great.
All right, back on the other side of 2. So we're into the other neighborhood now. Y equals 5. What does the graph of y equals 5 look like?
Just straight line.
Yeah, straight horizontal line up at 5. 1, 2, 3, 4, 5. Closed circle because y equals 5 owns the wall there.
Why is there such a massive gap between 1 and 2? I've just never noticed that. Because there's a misprint button. I don't have one. I'm hollow.
So for me, I like drawing the boundaries first. That helps me put the right graph in the right spot. The biggest mistake people make on these is to draw the graph outside, to cross into the wrong neighborhood. Right? You don't want to get caught in the wrong neighborhood at the wrong time. Bad news. Right? That's why your parents probably have restrictions on where you can drive. Like, stay in your neighborhood. Don't leave. Trouble. That's where those crazy y equals 5 people live. You don't want to go over there, right? Or if you're y equals 5, you don't want to come over in this neighborhood. It's very, very segregation oriented at this lesson. Number 9. So where are the breaks? Where are the walls? Where are the boundaries? 0 and 3. So I'm gonna. Yeah, we're gonna have 3 neighborhoods here. So at x equals 0 and x equals 3, I've got some boundaries going up. Again, I like to label them on the graph to make sure I put the right graph in the right spot. When x is less than 0, I want to graph y equals x squared. When we're at 0 to 3, we'll graph y equals negative 5. That should be an easy one to graph. And then when x is greater than 3, we'll graph y equals x plus 2. So 3 neighborhoods, 3 different graphs, no overlaps. Everyone has to stay in their own neighborhood. So y equals x squared, that's just the standard parabola. Although we're only allowed to graph it on the right hand or the left hand side here. Open circle or closed circle? Closed. So 1, 1, 2, 4, 3, 9, and so on. Now that's the preferred way to graph. Some people don't like graphing, like it feels like you graphed half a parabola. So with their pencil, they will graph the whole thing and then realize, whoops, I'm in the wrong neighborhood. Let me go back and erase and get rid of that. So if you need to graph the whole thing to help sort of see what's going on, you can do that. Just make sure you get out of the neighborhood as quickly as possible. Right? You take a wrong turn, okay, but get out of that neighborhood before you get caught over there. Y equals negative 5. Okay, that's an easy one. Horizontal line at negative 5. 1, 2, 3, 4, 5. Open circles or closed circles? Well, yeah, I asked that in a bad way. Open on the left and closed on the right because of the equal sign. Open on the left, closed on the right. All right, and the last one, y equals x plus 2. What shape is that? A line. Where do you begin graphing that line? At the 2. So if I begin at 2, what's wrong with, and then the slope is 1, what's wrong with what I'm doing right now? I'm in the wrong neighborhood. So this is a good one where it's okay to start in the wrong neighborhood because that's how I graph a line. I go up 2, B equals 2, that's where we begin.
Okay, so you always start in the point of origin, not in the beginning of your neighborhood.
Correct.
Okay.
And then when I get into my neighborhood, then it's like, okay, now I'm in the right spot. I can actually draw that line with an open circle, and I better go back and delete the part that was in the wrong neighborhood. So because we usually start graphing at the origin, sometimes you'll have to draw a little bit in the wrong neighborhood until you figure out what the shape looks like, and then go back and erase it if it's not in the right spot. So you're right, that's the common mistake, is to say, oh, I'll start by going up 2, and you start right there. You're like, well, that's not where you go up 2 from. You go up 2 from the origin. If you did want to start here, well, you'd have to plug in x equals 3. 3 plus 2 is 5. So you could do it that way, kind of plot points. That's not really that's kind of a long way to go, is plotting points. But it works if you need to do it. All right, so that's it for today. Graphing and evaluating piecewise functions. Again, once you learn how to ride a bike, it's not hard, but until then, you can get some scrapes and bruises along the way.